Hello, this recording is for Algebra 1, Chapter 7, Lesson 1, 0 and negative exponents. But first a quote from Horseradish by Lemony Snicket, Bitter Truths You Can't Avoid, page 75. A good library will never be too neat or too dusty because somebody will always be in it, taking books off the shelf and staying up late reading them. All right, back to math. 0 as an exponent. Any non-zero number to the 0 power is 1. So any number to the 0 power is 1, well, except for 0, because again, it's any non-zero number. So 2 to the 0 power is 1, negative 5 to the 0 power is 1, and 0 to the 0 power is undefined, and we will discuss why anything to the 0 power is 1 in Chapter 7, Lesson 5. I will explain it later, not now, which is why I disagree with the order of the book, but that's a personal issue. All right, so just know that any non-zero number to the 0 power is 1. All right, negative exponents. Any non-zero number with a negative exponent becomes a fraction with a numerator of 1. Now, sometimes you won't have a numerator of 1, but if you have just a straight number to a negative exponent, then yes, you're going to have a numerator of 1. I'll show you some examples of where that's not the case in a few minutes. Okay, so here's an example. We have 2 to the negative third power. All right, so basically, the negative exponent tells the whole power to move to the other side of the fraction bar / division bar. And when that move occurs, the exponent becomes positive. So negative 3 is like, hey, 2, let's move to the other side. And during the move, the negative 3 will become a positive 3. Now, since there was nothing left over on the top of that fraction, there was nothing that stayed up top, the numerator is 1. All right, so it becomes 1 over 2/3, which is the same as 1 over 8, because 2 to the third power is 8. Okay? All right, so let's say we have negative 4 to the negative third power. See how I have parentheses. That means that the negative 3 is going to affect the negative 4. So we're going to end up with 1 over negative 4 to the positive third power, because remember, when it moves, it becomes positive. And then we have 1 over negative 4 times negative 4 times negative 4, which is 1 over negative 64. So that's the answer. All right, now we have negative 3 to the negative second power. Notice how there's no parentheses. So the negative 2 is only going to affect the 3, not the negative 3. So we end up with negative 1 over 3 times 3, which is negative 1/9. All right, now we have 7 to the negative first. And that just means that the negative 1 is going to tell the 7, hey, let's move down to the bottom, and it becomes positive. 7 to the first power is just 7, which is 1 over 7. All right, remember, negative exponents move the power, base and exponent, to the other side of the division / fraction bar, and the exponent becomes positive with the move. Okay, so I hope you've figured that out by now. All right, I think, next slide. All right, so an algebraic expression is in simplest form when it is written with only positive exponents. Still need to simplify fractions, though. All right, so fraction bar is equal division. So let's say we have 4yx to the negative third. The 3x is, negative 3, that power is, the exponent is only going to affect the x. Now, if 4yx was in parentheses and then to the negative third, then the negative third would affect everything. But because there's no parentheses, the negative third power only affects the x. So let's go ahead and write that. There you go. It only affects the thing right in front of it. All right, so I can put that in parentheses because it's the only thing that's really being affected. So I have 4yx to the negative third. X to the negative third is the same as 1 over x to the third. And here I can just multiply fractions. What's 4y as a fraction? Well, that'd be 4y over 1 times 1 over x to the third. Multiply across. 4y times 1 is 4y. 1 times x to the third is x to the third. And we have 4y over x to the third, which is our final answer. Okay? All right, number 2. We have 1 over w to the negative fourth. Well, we can write this as 1 divided by w to the negative fourth. W to the negative fourth is the same as 1 over w to the fourth. And so now I'm basically dividing fractions. Well, how do I divide fractions? Well, that would be the same as multiplying by the reciprocal. Yes, you called it and I called it. And there you go. There's your reminder. So 1 times w to the fourth is just 1 times w to the fourth, which is w to the fourth. The other way you could have done this is just moved the w to the negative fourth up, because remember, a negative exponent tells it to move to the other side. Since w to the negative fourth was on the bottom already, moving it to the other side of the fraction bar means moving it to the numerator side. So it would just be 1 times w to the fourth, because remember, the move causes the exponent to become positive, which is just w to the fourth. 1 times w to the fourth is just w to the fourth. So again, you don't technically have to show all of this work, as long as you can remember this. Okay, well now you can't see it, so I'll erase it, but there you go, all right? Technically, you don't have to show that work, but you do need to understand how it works, because again, it's going to come in useful later. So if showing this work actually helps you remember, I need you to do it. You need to know, you need to understand why this works, not just that it works, okay? All right, next up, we have n to the negative fifth over v to the second. Remember, the negative exponent moves that whole power to the other side. Since n to the negative fifth is on top, it goes to the bottom, moves the exponent, becomes positive, and we have 1 over v to the second, n to the fifth, which is simplified. All right, remember, negative exponents move powers. Same note as on the last slide. So yeah, there you go. All right, so when evaluating expressions, write the expression with positive exponents before substituting values. So if we have n to the negative third times w to the first, the n to the negative third is going to move down to the bottom, because it was currently on top, and it's going to move down to the denominator, and the negative 3 is going to become positive 3. So we now have w to the 0 power over n to the third power. Now, since I have all positive exponents, I can substitute with the values of each variable. So we have 5 to the 0 power over negative 2 to the third power. And remember, when replacing a variable with a numerical value, put the value in parentheses. Check out that reminder. Okay, so we now have 5 to the 0 power, which is 1, and negative 2 to the third power, since it's in parentheses, is negative 2 times negative 2 times negative 2, which is 1 over negative 8. There you go, simplified. Isn't this answer so much more friendly than that answer? Yes, I quite concur. All right, so now we have n to the negative 1 over w to the second. The negative exponent is going to tell the n to move, which is going to give me 1 over w to the second, n to the first. Replace the w and the n, and we're going to end up with 1 over negative 20. All right. These are going to go a little quick because, again, I don't want this video to go too long. Some of you guys have a second video to watch after this. Some of you don't, so I will keep going. W to the 0 power is, there you go. That problem looks familiar. Anyway, 5 to the 0 power is 1. Negative 2 to the 4th power is 16. So you guys see the difference between here and here? It was still a negative 2, but because it was negative 2 to the 3rd power over here on the left, because it's to an odd number, it's going to stay negative, whereas here, when it was an even number, it's going to become positive. So that is your reminder that negatives to a odd numbered exponent remain negative, whereas negative numbers to a even exponent will become positive. And that's because a negative times a negative is a positive. Whereas a negative times a negative is a negative times a negative is a positive, a negative times a positive is a negative. All right, there you go. All right, another example, 1 over n times w to the negative second. The w to the negative second is going to move up, which is going to give me w to the second and over n, and that is going to give you 25 over negative 2. Again, you can leave things as improper fractions. We're kind of done with this whole mixed number business. Now, if you can simplify, simplify, but yeah, mixed numbers, yeah, gone. All right, last slide. All right, yeah, last slide. All right, so word problems. A sample of bacteria triples each month. The expression 5,400 times 3 to the mth power, that's what the little caret means, models a population of 5,400 bacteria after m months of growth. Evaluate the expression for m equals negative 2 and m equals 0. I'm going to do the m equals 0 first. So here you go. We have 5,400 times 3 to the 0 power. Well, 3 to the 0 power is 1. So 1 times 5,400 is 5,400 bacteria. So at the very beginning, at the 0 month, Before the month even started, we have 5,400 bacteria. Now let's do it where m equals -2. Well, m equals -2, which we'll talk about in just a second, is going to create a fraction. Yes, so it's going to be 5,400 times 3 to the -2. 3 to the -2 moves it down beneath the fraction bar and becomes m to the +2. So 5,400 divided by 9 is 655.5 repeating, which you can't have 0.5 repeating of a bacteria, so we're just going to round up. Maybe they're in the middle of multiplying, and you just count them at a bad moment. It's okay. So we have 656 bacteria. But what does this whole 0 month, -2 month actually mean? Describe which each value of the expression represents. So if m equals months, the 0 month is when we start observing the bacteria. And that could be like, all right, when you work in a lab, and especially if you work in a biology lab, you actually buy your bacteria. And they send you a little vial, and inside that vial of bacteria, vial is some nutrients and some bacteria. So on month 0 is actually when you might have received your bacteria. So at month 0, they could be like the 5,400 bacteria that they're going to send you from wherever you bought your bacteria from. -2 months is before you even received your bacteria. This is the bacteria that is being grown at the place that you then bought your bacteria from. So 2 months before we started observing the bacteria is the -2 months. That's before you even received the bacteria from the place you ordered it from. And again, there's catalogs. It's all very interesting and complicated, but not really the point of math right now. Anyway, all right, I'm done. Thank you. Bye.